Okay, guys, we're going to talk about today domain and range, how to read a graph, how to write it. We're going to talk about increasing, decreasing, and constant, and all that good stuff. All right, it's a lot of information. It's a little abstract. I understand that, but you guys will be okay. All right, let's talk for a minute about what domain and range is. When I say the word domain, what values on the x and y axis do you think of? Domain is what values? The x. Good. It's x values. How do we read domain? If you're reading a graph, you read it like a book. How do we read a book? Left to right, okay? Left to right. And we talk about range. What are the range values? Y, good, y-axis. And how do we read range? Up and down, okay. Where do we start? We start down. So you read range bottom to top, we'll say. Low to high, however you want to say it. We read range from left to right is your domain. Range is going to be from the bottom to the top. So we start down and go up. So in a case on a graph like this has a specific starting and stopping point. How do you know if a graph doesn't have a specific starting and stopping point? What's at the end? Arrows. Good. Does anybody know the difference between a closed dot and an open dot on a graph? Tell me.
When it's closed, it's the exact value.
Good.
When it's open, it's never actually reached it.
Okay, so we're going to say that's very good. Closed is included. Open is not included. Very good. Who knows what the notation on the ends when you're writing the domain and range? Do you use parentheses sometimes? We use brackets sometimes. When do we use a bracket? When do we use a parenthesis? Bracket is included. Parenthesis is not included. Everybody understand? You guys with me? Okay, so in this graph, if you are asked to tell the domain and the range, the domain is the furthest left over to the furthest right, and we read it on the x-axis. So I look at here, and I say, okay, where does this graph have values that start on the x-axis? -1, agreed. And where do they stop on the x-axis? At 4, perfect. Now, what do you notice about the dots? The one on the left is closed, and the one on the right is what? Not closed or open. So we'd have a bracket on -1 and a parenthesis on 4. Meaning, -1 is included in the solution set, 4 is not. All right, so we're going to do the same thing now with range. We read range from bottom to top. So what is the lowest value that is used on your y-axis? -5. And what's the highest value used? 4, okay? What is the notation on either end? Brackets on both, good. Now I have a question for you guys because this is going to come up. What if there was not an actual point that they made a point to say that's the top? It was just the top of the curve. Is it still included? Yes. Is there a point right here? Yeah, is there a point right here? Yes, anywhere that the graph exists, where it's like a solid line, that's a point. So it doesn't have to be like a big point that says hey, look at me. So if it's just like a curve like that, that right there is a point because it's a solid area of the graph. Just want to make sure you guys know that. Another thing that you're going to see is they're going to ask you for f of -1, f of 2, f of whatever. What is f of x, a fancy way of saying what letter? Y, right? So when they ask you, what is f of -1? Well, what does this -1 represent? The x value. So what this question is asking, what is f of -1? It's what is the y value when x equals -1? So I'm going to go over here to x equals -1, right? And I'm going to go down, and what is the y value when x equals -1? -5. So you would answer that question, f of -1 equals -5. the question f of 2. What that means is when x is 2, well, what is the y value? 4. So you would say f of 2 is 4. It's all that they're at, all that question's asking. When it says f of whatever, you say, oh, let me look on the x-axis, and then look to see what the y value is at that point. Questions? Okay, moving along. Let's talk about this. Do you guys have arrows on yours? Okay. We're going to talk about domain and range here. What is the difference between 7 and 8? Oh, that's a 9. What's the difference between 7 and 9?
The arrows.
The arrows. What does the arrows mean?
That's good.
Goes on forever and ever and ever, okay? So here's something else we have to remember. What kind of infinity is over here on the x-axis? Negative infinity. What kind of infinity is on the right side? Positive infinity, okay? So with our range, where is negative infinity? At the top or the bottom? The bottom, good. Negative infinity. And where's the positive one? At the top, okay? Does infinity have a definite stopping point? No. So when you are talking about anything with infinity, do you use brackets or parentheses? Parentheses. Good. Very good. Very important you guys understand that. Your notation will always have parentheses if you have a negative infinity or a positive infinity. So when I ask you guys this question, I say, okay, what is the domain of this function? It means what x values satisfy this graph? This one is much harder than number 9. You have to think about this for a second. This graph, the arrows means it goes on forever and ever and ever and ever and ever, right? So it's continually getting wider. So what values does it start at on the left-hand side? Negative infinity. And where does it go to? Positive infinity. God bless you. The arrows say, hey, we're going to extend forever and ever and ever in both directions. If I ask you what the range is, if I say, okay, guys, well, what's the range? Is this range the same? Is it negative infinity and just keeps going all the way up? No. We start at the bottom here, right? This graph starts down in negative infinity. It goes up, 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 and it stops where? At 1. So I'm going to write negative infinity to 1. Does it include 1? Yes. How? There's not a specific point. It's like a big dot that says, hey, I'm included. But how do you know it's included? Because the graph is solid at that point. If it wasn't, it would be like this. It would be like a hole. And they'd say, oh, it doesn't include it there. But that's not the case here. It actually is included. So what kind of a notation would I put on the end of my infinity here? I'm sorry, on the 1, a bracket. Good. That's going to be a big thing on your quiz, guys, that you have the right notations. A lot of you are going to be able to identify the numbers, but it's going to be like, ooh, do I use a bracket or do I use a parenthesis? I'm not so sure. So now, why is this one easier? Yeah, tell me.
Why is the x negative infinity?
Why the x values?
Yeah.
Because this is going to continually get wider this way and continually get wider this way. So you can use anything on the left-hand side all the way to anything on the right-hand side. Why is number 9 easier? Tell me. Dana, right? Yep. There's a fixed starting point, a fixed stopping point. So let's read left to right. Domain, left to right. Where does this graph start? Negative 4. Okay, negative 4. And where does this graph end? Positive 4. Are those points included or not? Yep. So they're both included. Perfect. Now let's talk about the range. We read from bottom to top. So where on the y-axis does the range start? 0. And where does it end? 4. Included or not? Yep, there you go. Perfect. If I said, what is f of 0? What is that question asking? What is the y value when x is 0? What would your answer be? Perfect. Good job. All right, how do we feel? The question is, how do you know that 0 is a bracket? Because right here where y equals 0, right here where y equals 0, there is a value that is included right there. Sure. I know this concept is very abstract. It can be hard, I understand. we don't have to worry about this right now. We're going to get into this later. We'll get into that later. Let's talk about the vertical line test. Have you guys anybody learned about that in middle school? What's the vertical line test? Pencil test. If you draw a vertical line and it only touches the graph one time, then yes, it's a function. If you draw a vertical line and it touches more than once, then what's your answer? No, it's not. So if you're asked to use the vertical line test, these are questions that you want like 10 of these on a test. Probably won't have any. But if I draw a vertical line at any point in the graph and it crosses more than once, it's not a function. So how many times does this cross? 2. So is this a function? Yes or no? No. Perfect. All right, draw a vertical line. How many times does it touch? Once. All right, well, what about if I draw a vertical line over here? How many times does it touch? Once. What about if I draw it over here? Once. Anytime I draw a vertical line, no matter where I am on this graph, how many times is it going to touch? Once. So what's my answer? Yes or no? Yes, it's a function. Good. Vertical line test. What about if I draw one here? What about if I draw it over here? How many times does it touch? Once. That means yes, it's a function. And what about over here? No, because it touches more than once. Now think about what that means if the graph touches more than once. That means I have a value here and a value here. What value, x or y, cannot repeat? X. If you have a repeating x value, if you have 2 2s, or if you have -4 twice in the x value, it will not be a function. So graphically, it's the vertical line test. If you have a list of points or something, if you have x's that repeat, it's not a function. The y's can repeat 19 times, doesn't matter. But it's our x values that are the problem. Okay, now, this is probably one of the harder things that we're going to do because it's hard. I'm going to try to teach you little tips and tricks to make this a little easier. But we're going to talk about intervals of increase, decrease, and constant. An interval is a time gap or time piece, all right? Increase. What is a graph doing if it's increasing? It's going what direction? Up. What about if it's decreasing? Down. What about if it's staying constant? It's just flat, right? It's staying the same. So if you read this, a function is increase on an interval when for any x1 and x2 in the interval, x1 is less than x2 implies that f of x1 is less than f of x2. Does that make sense? Right, that's math talk, right? That's not how we're going to say it. We're going to look at this. And I want you guys to remind yourself, how do we read domain? Left to right, okay? How do we read intervals of increase, decrease, and constant? Left to right. Write this down. You read increase, decrease, or constant on the, I'm going to write real big, x-axis. We read from left to right. I cannot impress upon you enough how important it is that you guys understand it's the x-axis. The y-axis does not matter. Why is that confusing? Because if you think of the words increasing and decreasing, what direction are you thinking? Up and down. I agree that this graph is decreasing from 4 to 1, 100%. But they're not asking how much it's decreasing. When they ask for intervals of increase, decrease, and constant, they want to know over the interval of when it's happening, the time that it's happening. That's your x-axis. We always read left to right, and we always read on the x-axis. So I always tell everybody, the first thing, when they ask for intervals of increase, decrease, and constant, and I say, oh, I don't want to look at the y-axis. Cross it off. Sometimes if you do that, then you're like, okay, it reminds you, those are not the numbers I'm looking at. If you cross them off, then they're not even there. So we're going to read our graph from left to right. So I'm going to write decrease. I'm going to write constant. I'm going to write increase. Can a graph increase more than once? Sure. Can a graph have decreases more than once? Yes, absolutely. You might have more intervals than just one. That's okay. But we read from left to right. So the graph at this first point is doing what? It's decreasing from left to right. Put your pencil on it. It's going what direction? Down. Now I told you, it is, yes, decreasing from 4 to 1 on the graph, but that's not what I want to know. I want to know the interval over which it's happening. So from where on the x-axis to where on the x-axis is this decreasing? From -2 to 0. And we're going to use parentheses. I'll tell you why in a second. So now I look and I'm going to say, okay, I'm still reading left to right. I have this piece right here. As I draw with my pencil, what is that piece doing? It's staying the same. So over the interval of what to what on the x-axis is my graph staying the same? 0 to 2, perfect. And then I'm going to use my color pencil again. And guys, I have color pencils you're welcome to use for every test or quiz you want to. But what is happening from here to here? The graph is going what direction? Up. All right, so we're saying that it's increasing over the intervals of from 2 to 4. From 2 to 4. Now I used parentheses. Why did I use parentheses? Anybody know? You can't decrease and be constant at the exact same time. So if you use a bracket, it's saying that the graph is decreasing and then becomes constant simultaneously, which doesn't happen. At some point, there has to be a shift from decreasing to constant or from constant to increasing. So you'd never use brackets on intervals of increase, decrease, constant, just always parentheses, all right? So remind yourself, no brackets. We only use brackets on domain and range. You guys okay? It's a little easier when there's specific stopping and starting points. I know sometimes it's not so easy to see, so let's draw arrows on this one. What do the arrows mean? Okay, it's going on and on and on forever. So if I asked you guys, what's the domain and range for this graph? Negative infinity, go ahead, to positive infinity. It's going, continually getting longer up and down, continually getting wider left to right. So let's talk about intervals of increase, decrease, and constant. Now there's going to be sometimes, guys, when you don't have an interval of decrease or you don't have a constant or something like that. That's fine. But it's going to ask for the intervals of increase, decrease, constant. So you have to say none. Don't just leave it blank because then I think you don't know. Again, how do we read a graph? From where to where? Left to right. So I'm going to put my pencil here on this graph and I'm going to follow the graph. What is it doing the whole time? It's increasing. So where is it increasing from? Negative infinity to positive infinity. Is there an interval of decrease? No. Is there an interval where it stays flat? It looks like it, but it really doesn't. There's really like a little dip in there. I'll make sure on the test or the quiz that you can see, like for sure. You won't have to guess. So you would say none here. There's none. No interval of increase, decrease, or constant. All right, let's put arrows again on this one. Before you guys even start, just look at the graph. If you look at it from left to right, what's it doing? It's going what direction first? Up, then what? Then what? All right, so there's two intervals of increase here. Let's go ahead and say, do I need to look at the x-axis or the y-axis? Intervals of increase, decrease, and constant. Where do we read it? X-axis. So I'm going to just, anything that has to do with the y-axis, I don't want to see it because I don't want to get myself confused. Now I look and I'm like, oh, okay, these are the only numbers I have to deal with. So I'm going to write down increase, decrease, and constant. Left to right. What is my graph doing on the left-hand side? Follow it. From negative infinity, positive infinity, what's going on? It's negative infinity. Is it negative infinity because I started down here? Why is it negative infinity? Where do we start? We read on the x-axis. So from left to right, it just happens to be also the same direction as the negative one. But we're going negative infinity to what? Where is the turning point? To -1. Perfect. Then what happens? Then the graph decreases. Well, it decreases from where to where? -1 to 1. Perfect. So you have a decrease from -1 to 1. And then the graph does what? It goes back up. From where to where? 1 to infinity. Is there an area that it stays constant? No. So you would just write the word none. There is a time, guys, when there's going to be a gap. When there's going to be no area of increase, decrease constant, but the graph is separated. We'll talk about that later. We don't have to worry about that right this second. But let's go ahead and put a point here and a point here. Make this a little easier. And then, so this is -2 over here, and this is 4 over here. Point is 4, and this point is -2, okay? We're talking about increase, decrease, and constant. What axis do we look at? X. So I'm going to cross off anything that has to do with the Y, because I don't want to confuse myself. So increase, decrease, constant. Left to right, what's the graph doing? It's increasing from where to where? -2 to 0. Perfect. Then what's it doing? Staying the same from where? 0 to 2. Perfect. Then what? It's decreasing from where? 2 to 4. And we're looking, it's decreasing over the interval of 2 to 4 on the x-axis from 2 to 4. Yes, I understand it's going from +1 to negative whatever, but you're only looking on the x-axis. How are we? I know this is kind of rough. All right, last thing I want to talk about. This is very simple. You don't even have to really worry much about this. What does the word maximum and minimum mean? What's maximum mean? Highest at the top. What's the minimum mean? The lowest, okay? So when you see terms like relative maxima and relative minima, that just means the high points in a graph or the low points in a graph. This graph obviously has a couple high points. If they ask for the absolute, they want the highest or the lowest. But the relative just means, oh, look, here's a high point, here's a high point. Minimum would be the low point. We're going to talk about that more in chapter 2 with like quadratics and stuff like that. But when they talk about relative minima, that means all the low, all the dips. If they talk about relative maxima, that means like all the peaks, the high points. And then you don't have to worry about the graphing utility. We're not going to use graphing calculators right now. We'll do that later on. But that's all I want to do for today. We're going to do piecewise functions tomorrow, which aren't as bad, I think, as some of you might think they had been. But we're going to do the second part of 1.3 tomorrow, piecewise functions, and then we'll have a quiz review for you guys to work on. If you want to work on it over the weekend, great. If not, we'll go over it on Monday. Sound good?